Good evening, very good evening. Um, am I audible and is my camera working fine right now? Okay, okay. So we'll start. Sorry for the delay, there was some technical issue. Welcome to the live session number 9 for this course, Affective Computing. And let me start by introducing the course instructors for this course. Professor Janendra Shukla from Triple IT Delhi and Professor Abhinav Dhal from IIT Ropar. I am Akanksha. I am a PMRF scholar in the Department of CSC at IIT Ropar and I'm the PMRF TA for this course. Um, in these weekly sessions, if you have attended any previous weekly sessions, so we basically try to discuss the previous year's questions from the assignments of that week's content. Okay, so it will help you to solve this year's assignment and cover the whole the whole week's content, and we discuss it in the form of problem solving rather than in the form of lectures. So I hope this session will be fruitful. So this week is all about emotional empathy in agents, machines, and robots. Um, so if you have any doubt at any point of time, you can please type in the chat box, or even you can unmute yourself and ask the question. So feel free to ask any doubts. Also, one more thing, I would like to request you that whenever there is some question, please try to answer. Just type the answer in the chat box. Just type the option. So if it is interactive, that will be better. So let's start with the first question. Okay. Which of the following statements are not true? Humans prefer to interact with machines in the same way that they interact with other people. Empathy is the capacity to understand what other humans are experiencing. Presence of empathetic responses by AI leads to be better, more positive and appropriate interactions. Appearance and function of a product has no significant impact on how people perceive it, interact with it, and build long-term relationships with it. Please try to answer. D. Okay. So, if we talk about AI and empathy, human interactions, when we interact with human beings, it involves complex emotional states. So, involves emotional and social dynamics that we want to replicate. When we are interacting with the machine, we are expecting that it should also behave like we are interacting with a human being. So, we want to replicate that in the machines. Empathy, what exactly is empathy? Empathy is the ability to understand and share the feelings of others, how others might be feeling, and getting that sense and respond accordingly. So, it involves recognizing and acknowledging the emotions of others, which is an essential aspect of social interaction and emotional intelligence. So basically, this week's content is more towards empathy, psychology, and so it's since affective computing is an overlap. So this week's content will be more theoretical. So please bear with it. I mean, that is going to be more on the psychology side. So yeah, okay. So it is an essential aspect of social interaction and emotional intelligence, and which is the desirable property in the machines. Okay, when AI it demonstrates empathetic responses, it can lead to a more positive and appropriate interaction with the user. Of course, if the machine is behaving the way we want that machine to behave, it makes the interaction more comfortable, and uh, yeah so we are actually expecting that machine to be behave in a certain way. Empathetic AI can better understand and respond to user needs, leading to enhanced user satisfaction and engagement. And the appearance and the function of a product have significant impact. How? Because if you're interacting with something which looks very robotic, then it's less likely to make, I mean, the interaction will be more engaging. It's very less likely. But if the appearance is nice, and you feel comfortable interacting with that interface or machine or robo, then it will be much easier and much comfortable to interact with that. So you will come back again and again to interact with. If you find, suppose there's a cute dog robo, so you will find it cute, you will want to come back. But when there is a weird looking metal body, all wires and all, that might not be appealing, and you might not want to interact with it again. So yeah, appearance and function of product, they have significant impact. Factors such as design, usability, and aesthetic appeal play crucial roles in shaping user experience and preferences. So yeah, this is option D. Correct. Next question. Shimi analyzes the human voice for arousal and performs semantic analysis of spoken language for emotion detection. True or false? So basically, let me tell you that the first 10 questions are from previous year assignment. After that, it's more new questions that we have. I mean, we'll be discussing to cover the contents of this week. So yeah, okay, true. Okay, let's see. So let's see what is actually Shimmy. So Shimmy, also known as Travis, it's a smartphone-enabled robotic musical companion that can respond to and enhance the user's musical experiences. So it was developed by a team led by Professor Gil Weinberg, director of Georgia Tech Center for Music Technology. And what exactly Shimmy does is that Shimmy is controlled by an Android phone using its built-in sensing and music generation capabilities. Music generation capabilities. It allows the easy development of additional custom mobile apps. Basically, there is this, um, it is kind of a dock, a mobile dock. You put your smartphone here. Let me use this. Okay, here you, not this one, this one. Here you put your smartphone, and if you like do tap, tap, tap in front of, like, and if you play this beat, and that robo is very smart, it will sense the beat and tempo, and it will suggest you a similar song with the same beats. So basically it's a robot to enhance your musical experience. So you can, based on your mood and preferences, you can interact with the robot, and it will play the music accordingly. So it also acts as a, it taps, it does the gestures also. This leg movement is also there, so it taps on the table. So yeah, it's more like a music buddy. So yeah, that is the motive, and it is actually they um, made it available for this industrial manufacturing also. So so yeah, I mean, okay, it is controlled, and this, okay, this is enabled Android apps. It supports Android apps, so you can also develop new apps which can be used in to utilize these sensors and modalities which Shimi actually has. So for more information, you can also visit the website, which is Georgia Tech. This link is also there. You may use this later. So here you can see that it moves. It's this head. Oh, it has camera sensors. Then it taps, and it detects the user, where the user is moving. And so yeah, that's the first application developed by Shimi. It allows the robot to listen to and analyze rhythms, you know, played by humans, and respond by choosing songs similar in beat and tempo from the music phone library. So this actually can be, and Robo then dances to the music using a set of expressive gestures that fit the desired tempo and genre. So on YouTube also, if you search, this is a very interesting video is also there. Shimi will understand your emotion based on how to speak and respond with this kind of emotion response both in gestures and in voice. So basically, it why are we studying this? Because it also is enabled for affective computing. Like basically, it uses affective computing. It can sense, for example, if I'm talking to this robo and I will say something, it can sense the emotion and how am I feeling, and it can play the music accordingly. So it's basically to allow it you to have a companion that is driven by music. So yeah, so this is true. Okay, next question. The dash task is a test that psychologists use to gauge development of the theory of mind. False knowledge, false belief, true knowledge. Okay, let me discuss this one. So this test is called false belief task. This is a very popular task which is used in psychology to assess the development of theory of mind in individuals, especially children. So they are mostly for the theory of mind, how our mind works, and it's very simple activity, and it's usually done on for the assessment of children, actually for toddlers or children. Okay, so basically what theory of mind is, that we want to assess that if they understand that others might have false beliefs that don't align with actual reality. If you know something, the truth you know, but then there might be somebody who might not be aware of that particular truth or the fact. But so the perspective of that person will be different from you, and are you able to understand that? Because this sounds very vague in our head, but for children's development, this test has been, it's being used since um, long time. So one example is the Sally Ann test. It's a psychological test. It is also, again, it is an example of this false belief task. So there are multiple tasks which can be false belief, come under the this umbrella term. So one of them is Sally Ann test. So it can be used in developmental psychology to measure a person's social cognitive ability to attribute false beliefs to others. So what it actually means is, um, what happens in this task is that there is a small skit. So there are children on which this test is performed. Um, these are kind of puppets. These are puppets. One is Sally. This is Anne or Annie. Okay, so let's call her Annie. Um, there is this one puppet called Sally. This is Annie. There's this bucket, and this is basket, and this is a box. Now the enactment goes like this: the Sally, she puts her ball in the basket, and then there's Annie. She can see. Sally goes away, okay, and Annie moves the ball to her box. Now, but Sally was not here, so she does not know. Now the question is, where will Sally look for her ball? Now this sounds very vague, but it actually helps in these psychological assessments. So Sally takes a marble and hides in her basket. Then she leaves the room and goes for a walk. While she's away, Annie takes the marble out of Sally's basket and puts in her own box. Sally is then reintroduced, and the child is asked. The child under consideration. Okay, they are asked that uh, question, the belief question, where will Sally look for her marble? So ideally the answer should be Sally should, because Sally still believes that the ball is here. So the basket, she should look in the basket. So basically this is the overview of this test, and this helps in this psychological assessment and all. So usually in case of autism or Down syndrome, so they can sense these things, these anomalies, or these uh, you know uh, so yeah, I mean, they can sense that the mental growth of that child is not in the right direction, or they can sense if there's any issues. So yeah, okay. So answer is false belief test. Okay. Next question is, humans prefer to interact with machines in the same way that they interact with other people. We've seen this one earlier. Would you like to answer? I'll wait for 10 to 20 seconds before moving on to the explanation part. True. Yeah. Again, it's true because um, again, we want to interact with something which is very familiar. Again, which is visually it looks like a human, or even if you see that there are, if even if there are cartoons, for example, there is a rat. Now, if the rat is behaving like a human, like he is wearing clothes, he's walking straight up, he's walking like wears glasses, then we can relate to that character. Children can relate to that character. It is more familiar, and we would be comfortable. However, if there's something very different from human, we might, I mean, full of wires and cables and sensors, which is not like covered and all, so that might not be very appealing to us. So say, in case of machines or robots, if it is very cute looking dog, or like has 2 ears and 2 eyes, then that will be more comfortable, right? Again, the answer is true. Okay, let's read this out. Human to human interactions are rich in social cues, emotions, empathy, and nonverbal communication, which are often absent in interactions with machines. While humans may seek assistance or perform tasks with machines, these interactions lack the depth and complexity of human to human interactions, right? The aim of HCI is to enhance the HMI or HCI is to enhance this user experience of interaction with machines. So yeah, so above mentioned things are desirable during human machine interactions to give a sense of comfort and familiarity, to make the interaction less robotic, right? So this is true. Next question. Okay. Tendency to provide human characteristics to non-lifelike artifacts is called. Anthro. Okay, correct. So, anthropomorphism is a concept which is deeply rooted in psychology and culture. As we know that affective computing is an intersection of computer science, psychology, and it's an interdisciplinary field describing the tendency to attribute human characteristics, emotions, intentions, and behavior to non-human entities such as animals, objects, or natural phenomena. Like we discussed the example of a cartoon character which walks like a human being on two like feet basically, and he's wearing glasses, reading a book, and lying on a bed in his so in his house. So all they just make these things more relatable and familiar. So it arises from our innate inclination to understand and relate to the world around us through human experiences and perspectives. Because we are humans, we want something similar. In design and technology, it often forms the creation of user interfaces and products that evoke human like qualities to enhance the user engagement and satisfaction. Now, for example, virtual assistants like Siri or Alexa, they're designed to respond to users in a conversational manner. It's not that robotic, they're very interactive. So it fosters a sense of interaction which is similar to human communication, right? So again, this is another example. This is a human and this is actual a dragon. But if it is behaving like a human, we find it more interesting and we find it more relatable. It's still a dragon, but it looks like a human. So this is an example. Again, let's look at another example. If you look at this robo, this might not be the best looking robo out there because it kind of looks creepy, kind of very uncomfortable to interact with because one eye, right? This one big eye is there, this mouth is very weird, and it's not covered. See, we can see the internal wiring and all. So very uncomfortable to look at, right? So these things should be avoided. These designs should be more like Sophia. Sophia looks like a human being, so it's not that creepy, right? We can interact with that. A robot designed to look like humans, two eyes and one nose, etc., would seem to be more relatable, and the users will be more comfortable interacting with. So, robot with four eyes and one ear, it might look creepy to the users, right? So, this is all about the concept of anthropomorphic design. So, yeah, the correct answer is B. A human appearance or behavior can make an artificial figure seem more familiar for viewers, right? But only up to a certain point, which is called flat flowed valley, YPO valley, empathetic agents, uncanny valley. Okay, so this is called the uncanny valley effect. What it means is, as we discussed in the previous question, that we want our robots and machines to look more like humans, right? Um, so, human like appearance or behavior in an artificial figure can make it seem more familiar and relatable to viewers, but only up to a certain point. Okay, Um, as AI figure becomes, as the artificial figure becomes more like humans, there's a point where it starts to elicit feelings of eeriness, discomfort, and revulsion in observers rather than affinity or empathy. Why is this happening? Because, see, if a robot looks exactly like a human being, then we also have the expectations that it will exactly behave like a human being. If a human looking robot, it's just not blinking its eyes, okay, it's just straight looking, like staring at your face all the time. Even if it looks more very realistic, you will find it creepy. You will find it creepy. Um, it will be uncomfortable to interact with that machine, right? So it, after a certain point, it becomes very uncomfortable. This dip in the emotional response, it's called the uncanny valley. Okay, so it suggests that while human like attributes can enhance familiarity and acceptance, there is a threshold beyond which overly realistic representations can trigger negative reactions due to subtle discrepancies between the artificial and the human. Of course, it cannot behave exactly like human, not at least at this stage. But so yeah, that becomes creepy. If you look at this picture, this is making you uncomfortable because the mouth region, this it, although it has all the character, all the features like a human being, but this area, it seems something off, something is off, right? Something is simultaneously strange and familiar. It's creepy. When robots appear close but not quite human, people tend to feel uncomfortable or even disgusted. So once the uncanny valley has reached, people feel again same afraid. Also, you can also be scared of that. Like they can look creepy. So this is the uncanny valley effect. So either you design something which is more embedded emotions are called, no, it's not like that. It's more about the mismatch. See, for example, if there is some cute looking robo which is not exactly, maybe it's all metal body but with 2 ears, like there's a robo we will see, it's called Kismet. Okay, Kismet, what it looks like, a there are two eyes, it looks like a pet dog, you can say. Okay, it has 2 ears, it kind of looks cute, looks good to interact with, it's like a pet. But, and if you know that okay, that this thing is a robo, this thing is a robo, you don't have that expectations that it will behave like a human, right? That is psychology. But if a robo like Sophia is very realistic, right? This this robo, suppose this robo, she's very realistic. But if she does something which humans don't do, if she like smiling like this all the time, like this is not something what humans do, right? Or maybe if she's not blinking, she's just constantly looking like this, that might, that look, a robo looking like a human being, you also expect that it will behave also like a human being. The expectations are higher then, and then there's a mismatch. For example, this the this one, you see, this actually seems to be a bit, you feel uncomfortable looking at it. If it is not even blinking and it's just directly looking at you, you won't be able to interact with it after a while, because it looks like a human but it does not do something which humans do. So there is a mismatch. It has not, it's not about more embedded emotions. I hope it's clear now. Do you have any other doubts? Yeah, okay. So, agents that respond emotionally to situations that are more congruent with the users or another agent's emotional situation are known as type 1 agents. True or false? So, this is very simple. Um, these agents are called empathetic agents. I don't know what's type 1, but empathetic agents, it defines empathetic agents. So, what empathetic agent mean is that agents that respond emotionally to situations that are more congruent with the users or another agent's emotional situation. These agents are programmed to detect emotional cues from users, okay? Programmed to detect emotional cues from users through various means such as facial expressions, tone of voice, text input, physiological signals, and contextual information. So, the primary goal is to establish a sense of emotional connection and rapport with users by acknowledging, understanding, and appropriately responding to their emotions, like humans do. They achieve this through a combination of techniques, including NLP for text, right? Speech processing can be there, using AI, ML, affective computing, behavior modeling, how your gestures are being noticed. So they can also use the behavior component. So yeah, it's a combination of multiple techniques. So this comes under the empathetic agents. So it's like, okay, again similar question. Empathetic agents are, I'll read the question out for you. Agents that respond emotionally to situations that are more congruent with the users or another agent's emotional situation. B is agents that by their design and behaviors lead user to respond in a way that is more congruent with the emotional situation. So this is yes, both A and B. Next. Yeah. Which of the following robot has had a very expressive mechanical face with anthropomorphic features? Kismet, Shimi, both A and B, none of the above. We have seen Shimi, right? I think, yeah. We've not seen Kismet yet. So let's see. Let's talk about this Kismet robo. See, this is what I'm talking about. Um, since we want it to look like a human, not exactly a human, but human-like characteristics, right? It has this facial features, two ears, two eyes, eyebrows, okay, this lips. Also, there is movement. This neck movement is there. It can move. So it kind of looks nice to interact with. It looks like a dog, right? Puppy. So Kismet is an expressive robo with perceptual and motor modalities. It can move also and it can sense your emotional aspects. Tailored to natural human communication channels. This you can also check out this video as well. So basically, it can sense where you are moving. It will move along. Okay, and if you seem sad, then it might respond accordingly. So it is equipped with visual, auditory, and other sensory inputs. Basically, movements are there. So motor outputs include vocalizations. It can like enact the lip movement also is there. Okay, if it is saying something, the lips will move. Facial expressions are also there. Motor capabilities to adjust the gaze direction. The eyes, they can move like this. So if you stand there, it will look there. If you move, it will move along and then look at you. And the orientation of head. So these motor systems serve to steer the visual and auditory sensors to the source of stimulus, which is the human who is interacting, and can also be used to display communicative cues. Right? Shimmy, we have seen this robo. As I already told you that Travis, it's also known as Travis now. So Travis or Shimmy, it's a robotic smartphone speaker dog and music listening companion. Travis is a musical entertainment robo computationally controlled by Android smartphone, and it serves as both amplified speaker dock and a socially expressive robo. Okay? It is designed to enhance a human machine music listening experience by providing social presence and audience companionship, and embodying the music played on the device, and it will tap according to the beats. Okay, and also there was one video. I don't know which version was that, because there might be multiple versions. Anyways, so that in that video, if you, it can also act as the DJ lights, or the it can project these lights, um, disco lights, not DJ, disco lights. So it can provide a whole experience of that party and all. So it's more like a music companion. So, but the main point was that it does not look exactly, it does not look like a human, right? But Kismet does have similar, like human-like features, right? So Kismet is the correct option. Okay. User feedback ratings are the potential methodological metric for evaluating the effective agents. Effective agents means these robots and machines that we are interacting with. So this can be a potential metric, evaluation metric. What do you think? It's true or false? Yeah, true. Okay. So how do we evaluate if there's a robo, you're interacting with it, how will you evaluate? There is, it's more of a, how you feel. How will you quantify how empathetic it was? So uh, the one of the like majorly used ways that user feedback. Maybe you can have a scale from 1 to 10 or 1 to 9, and maybe you can use some mannequins. Sam mannequins are also there. Like you felt good, happy interacting with that, or you did not feel good. So it can be in the form of visuals or numeric ratings, right? But the, yeah, the main thing is that user feedback ratings can be it can indeed serve as a potential this evaluation metric. So by collecting feedback from users about their interactions with the agents, the developers can gain insights into effectiveness in invoking in evoking um, emotional responses, as well as their overall performance and user satisfaction, because the ultimate goal is the user satisfaction, right? And the ease of experience, and the how well it is recognizing your emotional state and then responding accordingly. If somebody is sad and you are behaving like you're laughing, the robot starts laughing, the person will of course not feel better, right? So we need to work on these areas, so we can always get the feedback and identify areas for improvement. So this is true. Okay. Okay, again, what is anthropomorphism primarily concerned with? D. Are you sure? D. We just discussed anthropomorphism. So, yes, yes, because it's not about exploring human behavior, it's giving the machines or non human artifacts human like appearance or characteristics, right? So, creating machines with advanced technical features, this is not anthropomorphism. It's developing robot with superhuman abilities. No, firstly we need to develop human abilities. Exploring human behavior through AI research. No, this is not AI enabled psychology or like that. We need to. We are making the HMI more comfortable here. Okay. What is the primary reason for this giving this human like characteristics? B. Correct. Correct. Again, the sense of comfort, the sense of familiarity, the sense of um, they will come back. They will come back for further interaction. Otherwise, they won't. The users, I mean. Okay. What are the two main aspects of anthropomorphism that impact HMI? A human interaction with robots and agents. So is it appearance and intelligence, function and retention, appearance and function, interaction and capabilities? Okay, let's discuss this one. Actually, this is confusing. Yeah. So basically, there are two main aspects. One is appearance, and second one is function. Uh, Appearance we have discussed, like we want the physical characteristics of that robot or that agent, including its shape, color. You know, this is physical characteristics: shape, color, texture, overall design. It human-like appearance, having a face, limbs, or other human features can influence how humans perceive and interact with the robot. Okay. Now, second thing is function. It refers to the abilities and tasks performed by the robot, like capability, behavior, and the tasks it can accomplish. For example, just a very vague example, if you want to lift something, like the robot to lift something, so it should do like how humans do it. Just it should grab the handle of the bag and you know, hold it like this, right? But then what if the robot behaves something very weird, like it is not exactly behaving how humans expect it to be? So that's where the function part comes, although it looks like a human being. For example, that Sophia looks exactly like a human, but what if she walks on like a dog? That is something not related to humans. This is not, this is, there's a huge mismatch. So we want that how humans function, like how I'm using my gestures, it should also behave in a very similar way, right? It how effectively it completes tasks that can significantly affect user interaction and perception. So these are the two factors. Okay. What happens when there is a mismatch between the appearance and capabilities of a robo or agent? Yeah, it's more like psychology related, as I already mentioned, because there are more theoretical side. It's more about how we can make the machines more empathetic, and to invoke that empathy, to evoke that sense of comfort. How should we design the machines? So it's all about that. Like in previous weeks, we discussed some technical things like how are we going to process the speech modality. Um, so for like how can we use EEG data for emotions? There were tutorials. So, but this week is all about how we can get that sense of comfort and familiarity if we are interacting with machines. So yeah, that's that. So the exactly. This thing we have been discussing for a while now, that if there is a mismatch, something looks like a human being, but he walks like on four hands and feet, then we will be very uncomfortable and very creepy. Like one example is this uncanny valley, right? This one example can be zombie. So zombies in the movies, when you look at them, they look partially like they look like humans, but they don't behave like humans. So you will find them creepy, right? If if a robot looks like human and then it behaves like human, then it's no problem. And if something does not look like a human being, it's not behaving like human, that's understood. We don't expect it to behave like a human, right? The expectations are also lower. So yeah, again, something is off. When there is a mismatch between appearance and capability, it becomes uncomfortable. A very human lack very human like appearance but lacks the intelligence, may users may feel uneasy or disappointed. Actually, we will feel disappointed. Oh, he is not responding to my query in the way I expected, because our expectations are really high. If a robo has advanced capabilities but its appearance is not congruent with those capabilities, suppose there is a very simple as in there is no, it's not covered, all wires exposed and all. It can perform um, really good, like it can lift something, a bag up and move there like humans walk. But you won't relate to it because it might be confusing how wires are doing these things. We need something to look like human. So yeah, that's another, this reverse is also true. In either case, the mismatch can lead to discomfort and hinder effective human robot interaction. You wouldn't want to interact with that. Yeah. So D. Similar question. Okay. What is identified as a key factor contributing to discomfort in interactions with robots in the uncanny valley? Same. Exactly. The absence of human like appearance? No. The inability of robots to perform tasks efficiently? No. The mismatch? Yes. The inability, there's some typo. Okay, the inability of robots to accurately mimic human speech? No, nothing to do with that. So, yeah, there's a mismatch. Next question. Hmm. What are three major sub processes involved in empathy? Try to spend some time and try to answer this one. B. Exactly. Okay. So, okay. The three major sub processes involved are emotional simulation, perspective taking, and emotional regulation. So, what does emotional simulation means? That it involves experiencing the emotions similar to those of another person, often through empathetic resonance or mirroring. So, um, yeah, so we want to put ourselves in that situation. That's like how we usually define empathy, right? If um, we think how if we put ourselves in that situation and then think how would we feel, that's what empathy means. So experiencing emotions similar to those of another person, often through empathetic resonance or mirroring, it means that you're keeping yourself in that situation, okay, hypothetically. Second is perspective taking. So this is the ability to understand or imagine the thoughts, feelings, and perspectives of the other person, enabling one to see situations from their viewpoint. Again, similar. So, taking perspective, like putting yourself in somebody else's shoes, and trying to, then trying to like understand how the person might be feeling. Emotion regulation, it involves managing one's own emotional responses. If we are empathetic, if we are able to understand, but if we don't behave accordingly, if somebody is telling you their problems and you are laughing, then it doesn't make sense. It will have a very negative impact on the other person, right? So in order to appropriately respond and support the emotions of others, this is very important. For example, self control, empathy based decision making, and providing emotional support. Okay? So, yeah, again, like um, if somebody is feeling low, you should go and talk to them or let them talk, be a good listener. So this is you must decide what to do based on how the other person is feeling. Similar characteristics we want in machines. If I am tired, if I sound sad, the machine, my suppose there is a home robo, uh, whom I am interacting with, suppose be it Alexa. So I go home, I want, hi, hello Alexa, play this song, and then Alexa, if Alexa says, oh hi Akanksha, you sound so low today, what happened? So that will be very personalized thing, because that will be like a companion. Especially these can be very helpful when people are very shy to talk to, like introverts or people having social anxiety, they can have their personal robots or companions, or even in the application, one application is the elderly care. Um, there can be robots who can be there with the elderly people, who can sense when they are feeling lonely, and then they can play some upbeat song and refreshing song, or they can just talk to them. So that is also one use case. So in these situations, we want, firstly we want to sense what is happening, how the other person is feeling. Then we want to understand this perspective of the other person, and then behave accordingly, respond accordingly. So B is the correct option. So I have to explain every point, because many people will be watching this video later. So for your information, these lectures are being recorded, and these live sessions are being recorded, and we need to put this on YouTube channel, so that anybody who wants to go back and watch the video again, they can do at their own you know comfort. So uh, sorry. Okay. In context of therapy session vocal recordings, what prosodic features may be associated with low empathy situations? If somebody is going for a therapy session, and actually there is a data set, I forgot the name of the data set, but this data set has the recordings of therapy sessions. The voice is there, okay, and by analyzing those uh, vocal cues, we can um, analyze whether the conversation happening is empathetic or not. So how will we decide that this conversation is empathetic or not? It's, first of all, empathy is itself is a very complex concept, very complex. There is no standard definition for empathy, right? So, but still, in our daily lives also we have some um, common cues which we don't feel, which we don't find empathetic, right? So what can be these cues in this particular situation? So prosody, it means the style, the I'm stressing on some words, my style of saying something, like there's a tone, I'm just saying this, there's a tone. So like I'm kind of using my, there's a prosody going on. Okay, medium length segments with low energy and low pitch. Low pitch is usually very like heavy voice, and low energy, like I'm saying these things right now. Okay, let's talk about this, because uh, if you are comforting somebody, if somebody is not feeling well, and you are trying to be empathetic, then you will talk to them very politely, very calm, in a relaxed manner, right? Your voice will be very low, like, okay, I know that you're feeling lonely right now. I know that you're feeling lonely right now, but everything will be fine. So this gives you a sense of comfort, right? But what if I raise my voice, and in a very sharp, high pitch? High pitch is like um, very sharp, shrill voice. So that is kind of considered rude or not so empathetic, because in therapy sessions somebody is coming because their mental health is not that in a good condition, right? And if you raise your voice like that, it's not really considered a polite, right? So intonation plays a very important role. If there's a segment with high energy means that you're very excited and hyper about something, right? And high pitch means you're being loud and you're just raising your voice and being very how to describe that, shrill. Okay, it's like it may suggest that therapist is making use of a louder voice and having a raised intonation, and they are becoming more dominating in that sense. Okay, and yeah, because of this, the therapist's response within that particular segment cannot be considered as highly empathetic, right? So medium length segments with high energy and high pitch, if there are long segments, maybe it's a possibility that their voice is like that, right? But if there are very short segments, then it might be some noise or some reflex, right? But if there is medium length segment, that essentially that essentially means that there was some part of that conversation where the voice was raised. So that might be a case of low empathy, right? Okay. So, what are two main methodologies researchers use to generate empathetic behavior in virtual or robotic agents? Okay, so there are two methods, there are two methodologies actually. First is called the computational modeling, and second is the data driven approach. In the computational model, we have some theoretical model. Um, for example, we have predefined rules. If you see high pitch, then it means this. And if you sense some low pitch, then the user might be, um, how do I say, they might be depressed or sad. But if it is high energy, so it's most likely a happy or excited or surprise uh, feeling, right? So computational modeling, it involves creating mathematical or computational models that simulate human emotional processes and behaviors. Um, Researchers develop algorithms based on theory. This is based on theories of emotion and psychology to emulate human-like responses in virtual or robotic agents. If there is a robot with visual camera as well, it has a camera sensor, then if you are like smiling, it might sense that the user is smiling, so um, they must be happy, right? So it is basically it can sense the position. If this so if you have attended previous lectures, you might know that we can use facial action units for emotion recognition in using facial data, right? Now if if I make a rule that if the position of this upper like lip corner is upwards, they are like slightly upwards shifted, so that means happy, right? Because it essentially translates into a smile, right? And if I make these kind of set of rules, uh, maybe then we can use a decision tree or something like that. Okay, this is happening, then this is happening, then this is, then conclude that the person is happy and respond accordingly. So these include rules, logic, or decision making processes to determine how agents should respond in different emotional contexts. Okay. Also, they can utilize techniques from fields like AI, uh, affective computing to simulate matlab to enact empathy, right? A computational model of empathy might use a decision tree, as I mentioned, decision tree to analyze various emotional cues from a user and select appropriate empathetic responses. Example, if a user is sad, then the model could generate a response expressing sympathy or offering comfort based on predefined rule. If a person is sad, do this. If a person is happy, then do this. Then play this song. So this is predefined, right? But the next method is data driven, which means that we don't have this predefined set of rules. We use like some learning algorithms which is based on, like, we have annotated data. Like there's an image, the person looks happy. Just feed that images, that data set to a model. The model will learn, okay, these are characteristics, and the person is happy here. Now, it's not a rule based like that. So, machine learning techniques come under this category. It relies on collecting and analyzing real world data, for example, human interactions, emotional experiences, expressions, physiological responses to teach agents how to exhibit this empathetic behavior. Now, ML techniques, they are data driven because they use large data sets of human emotional data. Then they learn to recognize emotional patterns and responses by processing vast amounts of annotated data, and then they can adapt their behavior in real time interaction, right? Also includes sentiment analysis, effective computing, pattern recognition to interpret and respond to the emotional signals effectively. Example, we can use a conversation labeled with emotional states to train an ML model, and then um, model learns to associate specific linguistic patterns or cues with different emotions and adjusts. For example, you are saying, um, uh, why does this happen to me? Um, you're writing it in the text form also. It can analyze. So it can analyze the tone, the meaning is the person seems frustrated, right? Or um, nothing goes well with me. So the person might be depressed or sad. So you can sense it, and then the model, the agent can generate a supportive or understanding response based on the patterns observed in the training data. Okay, so these are the two approaches. Okay, next. Which of the following is not mentioned as a cue for analyzing empathy in interactions? Lexical, vocal, visual, olfactory. Okay, very simple again. Um, how do we analyze empathy? Actually, uh, just explaining because some of you might not be familiar with these terms. So lexical essentially deals with the text, right? These cues involve words or language used during communication. So certain words or phrases may indicate specific emotions or sentiments like happy, sad, excited, angry. If a person uses these kind of words, I'm so happy. So you can read the text and say that person is feeling happy. Second is vocal cues. If I sound so low, like uh, I'm so stupid, why did I do this? Then you can sense the sadness in my voice. But and if I'm surprised, oh wow, I got this gift and I was so happy to see that. You can see the excitement in my, you can sense in my voice. So this is also such as there are many features like tone, pitch, volume, intonation. um, these can convey different. Intonation also is very interesting because you might be saying something else, I'm fine, but you don't sound fine. So these can be used in combination with the text as well. um, A higher pitch and increased volume might indicate excitement, while a lower pitch and softer tone would suggest sadness or disappointment, right? Visual cues, of course, your facial features, facial expressions, non-verbal behaviors, um, body language, facial expression, gestures. A smile can indicate happiness or friendliness, but these like brows can signal concern or frustration, like why does this happen to me? Okay. Last one is actually related to the sense of smell, so it's not used for empathy. So yeah. Hmm. What does the term averted mutual gaze refer to in the context of analyzing gaze patterns? Averted mutual gaze. Gaze can also be um, an important feature to analyze whether the conversation is empathetic or not. So the general notion is that if I'm looking at you, then you might feel more comfortable, like, okay, I'm paying attention to you. And if I'm paying attention, that means I'm giving my time. And that shows the intent uh, of the other person in your conversation or in, helping you, counseling you. So the gaze is very important. So you can also use this gaze pattern. Or so there are three categories. First is mutual gaze. Mutual gaze means you are having a conversation with the other person and you both are looking at each other while talking. So that means the conversation is engaging, right? If a robo is there and the person is there and the robo looks at the person, then the conversation will be more engaging because the machine is also like the robo is also looking at you back, right? It indicates a mutual understanding or emotional connection between the participants, and this they it shows signs of attentiveness and empathy towards each other. One way gaze might be like, I am just looking straight, but somebody else is looking at me and talking. So I'm not looking at them, but they are looking at me. And that might not be much empathetic. That indicates disinterest. Like if you are telling me your problems and I look straight, I'm zoned out and I'm not even listening. It seems like I'm not even listening, even if I'm doing. Um, so that is another factor. Okay. So it basically shows that the other person lack of interest or engagement or possibly detachment from the interaction because I'm looking at something else. Thanks. I just try to cover the concepts in more detail. Uh, Also, the slides will be also available for your reference. So, okay. So, mutually averted gaze is that neither participant is looking at each other. If you are saying something and I am also like not looking at you, nobody's looking at the other person, that means either we are not like at all interested, and even it's the opposite of empathy, right? It's the opposite. Animosity is also like enemy. They're enemies, they're not even interested and they just don't want to look at each other's face. So that is exactly the opposite of empathy. Okay. There might be signs of discomfort, hostility, or disagreement expressed through facial cues, suggesting a lack of empathy or even animosity between the participants. So, averted mutual gaze. So, again, to summarize, in context of empathy, if we want to design an empathetic machine, then we should design like more mutual gaze should be there, or even um, the machine, if it's not looking at you, then you might not feel that engaged with that machine, right? But if it is looking back at, so we can put some camera sensors, and wherever you are going, the machine can also like follow, like we saw in the Kismet robo. It follows your direction and it turns, like it has motor capabilities as well. So yeah, either participant looking at each other. Okay. What is the first step in applying a computational model to generate empathy in an AI chatbot? Modulating empathy response, expressing empathy through messages, understanding the user's emotional state, analyzing user demographic information. See, let's see. Empathy in chatbots. The first step is applying this computational model to generate empathy is to understand the emotional state of the user. Uh, you need to sense how the person is feeling in order to respond accordingly, right? So we must understand first, and this can be achieved through various means such as users' language, tone, sentiment, or even physiological signals if available. So it depends on how many modalities are available with you right now. Uh, you can use single or multiple modalities in combination as well. Um, So yeah, so once the emotional state is understood, then of course we should, the chatbot should tailor its responses accordingly, because that's the whole concept of being empathetic chatbot. Because we don't want predefined messages. We want something, for example, if there is something we're designing a chatbot for Zomato, say food delivering company, and your order was not that good, or the delivery was very late, and if you are typing that uh, I'm very disappointed. My order was not delivered on time, and I was so hungry, and I felt very bad. Now the um, if the chatbot just replies you, sorry, we'll get back to you in a while. Um, that is some predefined text, right? But what if it replies like, hey Akanksha, I'm really sorry to hear that you had such a bad experience. We will work on that. And can you please tell me which restaurant was that, or what is the additional feedback that you would give? Like, it's more human, right? How restaurant manager would apologize to you, or would tell you, okay, sir, we are sorry for that. So basically, we want to put the emotional aspect in those chatbot. But what if a person, okay, I am very happy. Thank you for delivering my order on time. And then it should not be like, yeah, we'll get back to you soon, like that. So it should also tailor it. And it should not be like whatever it is saying to me, it should say to you as well. Because person to person customization of tailoring of the suitable responses by understanding the personality of that person, they can also adapt accordingly, right? So, yeah, first step is that we understand the emotional state. Okay. What is one proposed method for evaluating the effectiveness of affective agents? Likert, Likert scale analysis, Turing test, emotional intelligence assessment, facial expression recognition. B. Okay. So our motive, our goal of the like whole affective computing, this human machine interaction, is to make, I have said this numerous times, but we want the machines to behave like humans, so that we are not even able to judge that. Okay, I'm interacting with some machine. Like the previous example I just used. If you are not satisfied with your order from Zomato or some ABC platform, then what you can do is like you're complaining about it, and if you are getting the response from that side that okay, we are sorry to hear, but what would you like us to change, and like that. So it seems like a manager is sitting, a person is sitting there chatting with you. It is more personalized, it is more empathetic, and they understand you. So if you are unable to differentiate between am I talking to a machine or am I talking to a real person, then we will consider our system to be successful to pass the Turing test. If you don't know, like everybody knows, okay, a Turing test is um, if a machine is able to fool a human, then it can be considered like it passed the Turing test and it can be considered good. So, it is a proposed method for evaluating the effectiveness of affective agents. It assesses the agent's ability to exhibit intelligent behavior indistinguishable from that a human. In Turing test, for example, there is a human evaluator. I'm sitting here and I am having two chat bots, two chat boxes. So I'm doing this. I'm chatting with both of them, and I'm unable to tell which is machine and which is human. So then we will say that our system is very good. We cannot reliably distinguish between human and machine based on responses, and machine is considered to have passed the test. A high level of effectiveness in simulating human-like behavior, which is our end goal, and potentially empathetic interactions, right? So the correct answer is Turing test. Yeah. What types of cues were monitored by the affective auto tutor to determine the appropriate response? Only facial expressions, conversational cues, body postures, voice data, conversational cues, only body postures and conversational cues. B. Okay. So, firstly, we'll talk about auto tutor and then affective auto tutor because they're slightly different. Okay, auto tutor is an intelligent tutoring system that helps student compose explanation of difficult concepts. This is designed for Newtonian physics. It enhances computer literacy and critical thinking by interacting with them in a NLP, natural language actually, with adaptive dialogue moves similar to those of human tutors. There is a avatar and there's this video playing, and you can like type in your query, and that the avatar will respond accordingly. Maybe it's in the form of visual expressions or this auditory uh, response. Uh, so it constructs a cognitive model of students' knowledge levels by analyzing the text of their typed or spoken responses to its questions. So it will ask you some questions as well. So it is essentially the tutoring concept, but effective and intelligent. So it is used to dynamically tailor the interaction towards individual students' zones of proximal development. Affective auto tutor takes the individualized instructions and human-like interactivity to a new level by automatically detecting and responding to emotional states in addition to their cognitive states. So if a student is not feeling well in the sense that maybe um, it senses that the student is feeling stressed out or frustrated, then the tutor might not um, raise their voice because the person is already frustrated. You might want to use a uh, you know uh, more like calm sort of tone, right? Soft tone, to avoid any kind of further frustration for that student. um, we have that image as well. So it uses a decision level fusion where each channel, so there are multiple channels which can be conversational, which you are typing and chatting with that auto tutor. Face, they're capturing your facial expressions. Like, okay, if they're explaining some concept and you're saying like, I'm not, like you seem confused, then they can repeat it as well. Okay. And the posture is also like if you are sitting like this, then it means that you're not interested or the content is not that interesting or engaging, or the tutor needs to reiterate the concept. So yeah, I mean, they can judge the person is not interested or the less engaged or not uh, feeling well or stressed, etc., etc. So these individual diagnoses are combined with an algorithm that selects a single effective state and confidence. Again, different modalities are there. Maybe physiological. You can also use some physiological, but it's not feasible in real life, right? Physiological is something you're putting sensors, but here we are non-intrusive nature of the modalities we are using that. Then this is the interface of auto tutor. Actually, here you can see the this question like how does operating system interact with the word here program when you create a document. So it is explaining the concept. So student like, okay, tutor I see, okay, elaborate, and then your response, you're writing your responses here. This is the box. So this way you interact with this auto tutor. This is simple auto tutor, okay, but effective one, it has this body language, BPMS, uh, body posture monitoring system, I guess. Then this auto tutor, which is the type chat box, which is giving, which is collecting the contextual cues, conversational cues, and then there's camera facial features are being captured. So this is actually analyzing your affective state. So B is the correct answer. Okay. Minimal variability in empathetic responses adds complexity to accurately perceiving empathetic behaviors in computational model. Just read that again and try to answer. True. Okay. Let's see. Minimal variability in empathetic responses. Variability means the variations, right? And minimal means lesser. Do you think there is minimal variability when uh, we are interacting with a machine? Then okay, there's one machine, there's one robot. Uh, how the other person behaves with that robot responds to something, it's very different for everyone, right? People are, they all are different. We all humans are different from each other. How the way we think, the way we respond to things, it's all different. So there is a high variability, right? High variability because it's not necessary that if you will feel happy looking at something, I will also feel happy. So now this variability, uh, if there were only a few states defined, maybe two three responses would have been there, the complexity of the model design would have been very less, because we need not consider each and every kind of response, right? But it's the other way around, right? So complexity in computing empathy is when there is minimal variability, it implies that the range of possible reactions or expressions can be can produce in response to different is limited. It's limited. But in this scenario, the model's behavior becomes more predictable, right, and less nuanced. However, it's not the case with the real life interactions because humans are more complex. Our emotions are very complex. So, even like empathy itself is very complex. How are we going to judge, right? Um, so, overall complexity of accurately perceiving empathetic behaviors, computational model decreases because there are fewer possible outcomes to consider in case of minimal variability. This is with reference to minimal variability, which is not the case actually. But this does not happen. We have usually the range of responses is very broad. So we don't have a minimal variability. We have high variability in real life. So high variability in real life, high variability, which means that systems are usually more complex. So this is false. Yeah, I hope you got the point. Okay. What is a major challenge in integrating cognitive models of empathy into computational models? Computational means well defined rules, right? There were two approaches, computational and data driven. So, if we want to design a logic, what is that thing that hinders it the most? So, basically, what happens is that this computational models means that there is something well defined model. Now this well defined model means we must know what exactly, how exactly empathy translates into, um, for example, there are if you are feeling empathetic, then you must be uh, your body posture must be like this, or if you're feeling empathetic, your expressions will be small, like not small, slightly um, on the happier side, or you must be smiling, or whatever. So, but it's different for everyone, right? There is nothing common ground to define these concepts because psychology is very complex, emotions are very complex, and so is again empathy. So, is empathy well defined? No. Imagine a group of researchers who are interested in developing a computational model, okay, rule based model. If this happens, if the person is, um, if we sense this physiological signal, then if we see the smile on the face, then what happens? And if we don't see him smiling, then this. So, well defined rules, right? Each researcher comes from a different academic background, theoretical perspective. One researcher may say uh, importance of perspective taking, कि perspective taking is the most important. Other might focus more on the emotion part. The other one, they can be more of a theory person, so they might be theory of mind principles you should apply. Everybody has their own beliefs. Everybody has their own definitions of empathy. So they might not agree upon something very like common ground. So um, that is something very you can say very vaguely defined. So it becomes really difficult. You can't construct predefined rules if that the concept itself is not defined properly, right? So, of course, they will face challenges in integrating diverse perspectives into a unified computer that works for everything. No, it can't be there. Some conflicts will be there, and the lack of consensus it complicates the integration, highlighting a major challenge in the field. So, which of the following is not one of the elements involved in evoking empathetic responses? Type of behavior, time synchronization, appearance, context. Context. Are you sure? Let's see. First is the type of behavior. Okay, let's discuss this one. Type of behavior means, okay, let's read out the question again. Which of the following is not one of the elements involved in evoking empathetic? If if we want to evoke empathy, how how we can evoke and how what does not contribute. Let's see. Type of behavior. If there is a robo and how that robo is behaving, they if they are not even paying attention to you, if they're not paying attention to the user, then you won't be able to evoke empathy, right? But if it is paying attention, then of course you're like how you behave, it impacts evoking empathy. So it is important, right? Example, if AI responds to users distress with comforting words, if you sense that the person is depressed or sad, then you feel then maybe Alexa will say, don't worry, some days are good, some days are bad, you will get over it, it will get over. You might feel very good, you might be, you know, happy. Um, but if AI's behavior is dismissive or indifferent, it may not evoke empathy if it is same response for everyone. So that is not personalized, that is not something you would relate to. So that the type of behavior is important. Second is time synchronization. See, time synchronization is something not exactly related. It might not directly influence the response, but the timing should be correct. Of course, that is there. The timing should be there. Like, what if there's some um, trigger or some stimulus, and you're responding after such a long time, long pause? There's no use. The person will not be, relating to that much. But the timing is important, but it does not evoke empathy as such. Okay. Appearance, of course, it does. We have discussed this numerous times in this lecture. Because if we are mimicking human expressions or human experience, then human appearance, then of course it will be more, comforting. And the last is context. If context is really important, actually context is what differentiates you and me. If you are interacting with that machine, it should understand what are you talking about. Like if you want to share something, for example, if a user shares a personal story of loss, then AI's response should be sensitive and empathetic to the context of grief, because it should sense. And if somebody is saying a happy story, telling it a happy story, then it should behave accordingly. So, understanding the context is actually very important. So, time synchronization is the least important, you can say. Okay, it's not directly related, but of course, time synchronization should be there. Okay, what is highlighted as one of the capabilities of the Kismet robot? It can perform complex mathematical calculations to understand human emotions and respond empathetically, skill in mimicking human speech patterns perfectly, or proficiency in physical tasks such as lifting heavy objects. Exactly. Uh, Kismet, the empathetic robot, we call it. It's known for its specialized capability to understand human emotions and interact with people in an empathetic manner. It's designed to express emotions through tone of voice, facial expressions. In one of the previous lectures, also, Kismet was discussed, and there was picture. Kismet can actually smile or do like this, so sad expression. So it can change the expressions as well. So it actually it is very engaging to interact with that you know robot. So it can change the tone, facial expressions, body posture. It allows to engage in face-to-face interaction with humans and respond appropriately to their emotional cues. Now, this ability distinguishes Kismet as empathetic robot rather than focusing on trivial tasks. Not trivial actually, but mathematical calculations or speech patterns or physical tasks. What type of data does the empathetic companion system again? I mentioned it briefly. Analyze to gauge or gaze the user's emotional state. Heart rate, blood pressure, skin conductance, electromyography, respiration rate and body temperature, brain wave activity. B. Okay, it's true. So, what exactly is empathetic companion system? It is an animated interface agent that accompanies the user in the setting of a virtual job interview. Actually, this is not like that companionship for elderly or that is a separate use case. This is empathetic companion system which has been used for preparation of interviews. Let's say um, this this is actually really helpful for people who have social anxiety and who don't want to appear for a mock interview or something, and they can use these kind of tools to enhance their capabilities. So it is an animated interface. It takes physiological data. There are two modalities here. First is the skin conductance, which is uh, galvanic skin response or skin conductance, basically the measure of activity of your sweat glands. So if you are excited, etc., then I mean, um, if you're excited state, then the sweat glands activity increases and the conductance also increases. And this is second one is the electromyography, which is related to the muscular activity. For example, if you are stressed out, if you have tension, like so, you might be feeling tensed in your muscles as well. So it can capture that feature uh, as well. So it interprets them as emotions, then addresses. So there are two. This uh, interprets them as emotions and addresses the user's affective states in the form of empathetic feedback. The empathetic companion is conceived as an educational agent that supports job seekers preparing for a job interview. Okay, yeah. So like Shima character, there's some Japanese, I guess, characters. I apologize that there was a delay in posing the question. So if there is a time delay, then he's apologizing. So that's empathetic, right? Another example is like this. If you pose a question and then see that the other person, the interviewee, is not feeling comfortable or like that, so it might respond, it might change the question and say, oh, I it seems that you did not like this question so much. So for example, the question might be, um, what kind of, what is the mm package that you're expecting, which is sometimes uncomfortable. Okay, so might be this kind of a question, and here like it can respond accordingly if you are if you want to show empathy, then who is aroused and has a negative balance. For basically, arousal and negative balance means maybe they're scared, right? Um, so I'm sorry that you seem to be a bit bad about that question. So it can respond that way. Encourage, if it is not, if they're not aroused, we want them to we want them to give a friendly comment like you appear calm and you don't have to worry, keep going. Okay, so maybe the balance will be more positive after that. Ignorance is also there. Let's go on to the next question. It's okay if you can't answer that. Congratulate, well done, good job. If the user is aroused in a positive way, then you should respond accordingly. So yeah, these are some examples. Again, uses skin conductance and electromyography. I've already discussed about these things. Tension or relaxation, it deals with the muscular tension and relaxation. These physiological signals can be sensed in real time, then we can tailor the responses accordingly. How does Shimi, the personal robot, communicate with humans? Shimi, we saw that the musical robot. B. Okay. Yeah, so basically, Shimi communicates with humans through music, gestures, and verbal responses. And the communication is driven by music. Basically, it taps on the table like this. Okay, and it can move the that neck like structure. It analyzes human speech for emotional content. Hey, Shimi, I want you to play something happy for me or upbeat for me. So it can also respond in an emotional way. It incorporates gestures and movements to enhance its interaction with users, providing a multimodal communication experience. So through music, gestures, and verbal responses. Okay, this question, which is not correct regarding the false belief test. The false belief test is used to assess an individual's theory of mind, particularly in adults. In the test, participants are presented with scenarios where someone holds a false belief about a situation, and the test aims to determine whether the participant can understand that others may have beliefs that differ from their own. Just read it again and try to answer. D. Three only. Okay. We discussed this Sally Annie example, and there we want to assess that whether the person in consideration, under consideration, can understand that the next person can have a different belief than you, right? And they have belief that because they are unaware of something, some facts, so they might differ in some opinions. But some uh, children, especially who suffer from autism or different, you know, these I shouldn't say abnormalities, but specially abled, uh, uh, these things. So they're unable to process this. They're unable to process this simple information. That's how they are, analyzed, and that's how maybe this can also be used in the diagnosis process. So the the correct answer is it's actually used for mostly for children. Okay, the first point is false. It's not correct. Second point says in the test, participants are presented with scenarios where someone holds a false belief about a situation. False belief. The person Sally, she went outside. She does not know that the ball has moved to the box instead of the basket. She holds a false belief about something. So that's the concept, and we want that uh, you know we want to determine whether the participant can understand that their this point of view uh, Sally has, it might differ from there because they know what is the truth, but the other person does not. So again, often I administrate to children. It's widely used for psychology, mostly psychology, in developmental psychology, to assess individuals' theory of mind, how mind works. It's very complex thing, which is the ability to attribute mental states such as belief, desires, intentions to oneself and others. Aim is to so that whether the participant can understand and accurately predict that other might have beliefs that differ from their own. This thing can help you when you are dealing with something. Maybe conflicts are there, and you still want to be empathetic. That you might have a different opinion uh, than others, but you might want to understand them as well. So this ability to recognize and understand false beliefs is to it's considered an important milestone in development of theory of mind, as it demonstrates an understanding of subjective nature of beliefs. It's not objective, it's subjective. It depends, varies from person to person, and ability to attribute mental states to others. So the correct option becomes one only. This is not correct. I don't know about how SSB interviews go, so I'm unaware about that. But glad to hear that. Okay, so we reached the end of this session. This was the last question for this session. This was more on the psychology side. I'm also learning new concepts through this course, and I hope the session was helpful. Um, so we have this session. Uh, oh, okay, I got it. So, uh, so yeah, we have this weekly sessions on every Tuesday from 6 to 8. I think you must be getting the mails as well. The content is available. The slides will be available on the Google Drive link that is being shared. Then there is the recordings of these lectures that go on a YouTube channel, and the links will also be provided to you. Also, the next session will be oh yes, I forgot to upload VK slide. I will do it today only. And the next session will be on 2nd of April, and I hope to see you in the next session as well. Um, Also, if you have any queries, any feedbacks regarding the session, you can also always, you know, welcome to um, share your views. And this is that's it for this session. And I thank you for joining. So we will end the session now. You may please leave the meet. Hope to see you in the next session as well.